All right, welcome back to Chapter 3, Exponents and Roots. We are going to be discussing Lesson 7, the real numbers. So let's talk about real numbers. If we're going to talk about real numbers, the first thing we have to talk about are the natural numbers. So the natural numbers, I should just write natural numbers. I'll say just numbers like this. The natural numbers are numbers that you just naturally count with. So if I was going to count, let's say these pens, right? It would be 1, 2, 3, 4. Okay, I naturally count that way. So those are the natural numbers. So 1, 2, 3, 4, and then so on, right? So those are the natural numbers. And there's more numbers than that. After the natural numbers, what you have is you have something that is called the whole numbers. And the whole numbers are all of the natural numbers. So 1, 2, 3, 4, that is a whole number. But what's included is 0. So 0, 1, 2, 3, 4, 5, 6, all the way up. Those are all of the whole numbers. So this circle represents that it includes 0, but also everything inside the circle, all right? So that is whole numbers. Now, once we have whole numbers, we can talk about the integers. Okay, and so I'm gonna put integers over here. Now, integers include everything, right? 0, 1, 2, 3, 4, but it also includes negative numbers. So like -4, -3, -2, -1, 0, 1, 2, 3, 4. These are all integers. Okay, and there's also -5, just any positive and negative whole number that's not a decimal or fraction. That is an integer. So integers are also whole numbers and natural numbers, okay? Now, after that, what we have is we have rational numbers. Put rational numbers down here. So rational numbers are, they can be fractions or decimals, but they have two characteristics. So the decimal either repeats or it terminates. So something like this. So if I have 3/4, that's a rational number because the decimal 0 is 0.75, it terminates. Also another fraction could be 1/3. 1/3 as a decimal is 0.33333. I'm going to put that vinculum on top, which means it repeats. You could also have something like negative. It could be -1/4 because as a decimal, it terminates. 0.25, it stops. So these are all rational numbers, okay? But also a rational number includes all of these as well. So it can be an integer, it can be a whole number, it can be a natural number. Okay, so after that, we've talked about rational numbers. What we have next are irrational numbers. So irrational numbers are over here. They're kind of in their own little thing. Irrational. Did I spell that? I don't think I spelled that right. I did not. Okay, so irrational numbers. And irrational numbers, those are numbers written as decimals that don't terminate or repeat. So something like pi, that is an irrational number. It's approximately 3.14159 ... It keeps going on and on forever. So that's why it's not a rational number because it doesn't terminate. It keeps going on forever. So that would be a irrational number. Also square roots, like square root of 5. Square root of 5 is also a number that's going to go on forever. So any square root that's not a perfect squared number, so like the square root of 7, that would also be an irrational number. Okay, so these are in their own little group, irrational numbers. Okay, so this right here, it says, what kind of numbers can only be written as decimals that do not terminate or repeat? Those would be irrational numbers. Okay, these ones right here. And the set of what numbers consists of the set of rational numbers and irrational numbers. Okay, so there's actually a set that combines both of these, and those are called the real numbers, which is what this whole section is about. So real numbers is about everything. Real numbers includes irrational numbers, and it also includes rational numbers and integers and whole numbers and natural numbers. All of them, real numbers. And if we're talking about real numbers, there's also imaginary numbers, but you're not going to learn about that till later, but I'll just give you a preview. Imaginary numbers, they're in their own circle, and it would be something like if you have the square root of a -9, right? We know the square root of 9 is the same thing as 3 squared, and that square root cancels out that square, but when we have a negative number, it ends, oh my goodness, where's my friend? It ends up being, so the square root cancels out the squared, and the square root of the a negative ends up being 3i. And so those are imaginary numbers. But you won't learn about those until Algebra 2. All right, so we are going to stick in this real numbers realm, okay? So here it says the set of real numbers consists of the set of rational numbers and irrational numbers. Okay, let's go ahead and look down here at some examples. Okay, so we have, it says, example 1, classifying real numbers, write all the names that apply to each number. So square root of 5. Is 5 a perfect squared number? It is not. So that means that it is an irrational number, which also means that it is a real number. So we're going to say that this is an irrational number, and it's also a real number. Perfect. Okay, let's go here to -12.75. Okay, so this is a decimal that terminates. So that means it's going to be a rational number and also a real number. So it's a rational number, and all rational numbers are real numbers. So it's a rational number and a real number. Perfect. All right. Okay, let's look at this one. C, square root of 16 divided by 2. Okay, so let's do a little work here. We know that 16 is a perfect square number, right? So that's the same thing as the square root of 4 squared all over 2. Square root and squared cancel each other out. We're left with 4 over 2. 4 divided by 2 is 2. So that is our number that we're looking at. So if we go up here, we know that 2 is a natural number. It's a whole number, it's an integer, it's a rational number, and it's also a real number. So it's all of those. So it's a natural number, whole number, an integer, a rational number, and a real number. It's a lot of numbers. Whew, that was a lot. Okay, now it is your turn, ladies and gentlemen. I want you to try D, E, and F, okay, on your own. Here's my friend, the pause dragon. Remind you to pause your device. Go ahead and work out D, E, and F. When you get done, press play, and we'll talk about them together. All right, see you in a bit. All right, let's see how you did. So we have this -47.675. This is a decimal that terminates. That means it's going to be a rational number, which is also a real number. So this should be a rational number and also a real number. So if you got both of those correct, awesome job. If not, go ahead and change your notes so they look the same as mine. All right, square root of 3. 3 is not a perfect squared number, so that means that this is going to end up being a decimal that does not terminate or repeat. It just keeps going on and on forever, which means it is an irrational number. And all irrational numbers are also real numbers. So if you got those right, great job. Okay, on to F. We have the square root of 81 divided by 3. We know that this is a perfect squared number, and 81 is the same thing as 9 squared. The square root and the squared cancel each other out. We're left with 9 over 3, and 9 divided by 3 is 3. So we know that this is a natural number, a whole number, an integer. Oh, that is not how you spell integer. Inger? What is that? Oh my goodness. Okay, but I have my friend, and it helps me. Okay, so integer, that's how you spell that. It is a rational number and a real number. And there we go. So if you got all of those right, you did a wonderful job, and I'll see you in a little bit for example 2.